somebody said it's whatever's leaving PBR1. How do I know that? Does the flow rate of A change across the purifier? No. Yeah. And that is also equal to the inlet flow rate to the first PBR times 1 minus the conversion within that first PBR. What about CA naught squared? What's concentration equal to? That's total concentration. But that's a good point. We have an equation for concentration, for total concentration in terms of things like pressure and temperature, right? Yeah. So now we just want to multiply that by the molar fraction of A, and then we can put here the total concentration of all species in the second inlet stream. And YA naught is equal to the flow rate of A naught going into the second reactor divided by what? The total flow rate going into the second reactor. Alright, so we're going to solve it as if 100% of B is removed. So in here you have A and C, here you have A, B, and C. Here you just have A, and here you have A, B, and C. Correct? Alright. So the total flow rate of streams entering the second reactor is equal to what? Right? And because A and B aren't changing across this purifier, I can also just write that as FA1 plus FC1, where that means leaving the first reactor. Which means I can also write it as FA naught times 1 minus X1 plus FA naught times X1. So because I've removed all of B from the unit, delta effectively becomes 0, right? In terms of what will actually go into the next unit. So the total flow rate of species leaving or entering the second unit is the same as the total flow rate of A entering the first unit. And then CA naught squared is just going to be, right, YA O2 times the total concentration equal to the flow rate AO2 over the total flow rate times total concentration. And so what is this equal to? So what's this? This is FA1. So FA naught times 1 minus X over FT naught. And what's FA naught and FT naught? are the same. And here, this is again 1, and this is just YA naught, which is that piece, so it's just equal to that. YA naught, which, remember that's FA naught over FT. That's the same thing as here, so it's 1 minus X. Times delta, and delta is 1. So can I solve for these parameters? You wouldn't actually be given X1, would you? What would I need to give you for you to solve for all of these numbers? I need to give you the flow rate entering the unit. Did you get that?
Yeah.
Yep. What else? Somebody said weights. You don't need to know weights. Oh, weights. Yeah. You mean of catalyst?
Yeah.
Yes. You need to know the weight of the catalyst in the first reactor. That's the only way that you can calculate the conversion through that reactor. Not the volume, but the weight. This is a PBR, not a PFR. So literally, I can't believe you did this on the test. It was a long time ago. Forgive him if you ever see him and you want to hit him for it. The answer, you're just supposed to write down on a test not enough information, which you guys have had that trick question before. Everybody hates it.
Damn.
But yeah, that's what these say. They write it out. You know, they put everything. I could ask you to solve for it in terms of X1, for example. But it says in here, need X1 to evaluate parameters, but not enough information given to get X1. Need to know W1.
Has a teacher done that to you?
Huh?
Has a professor ever done that to you?
Yes. I was actually, that happened to me. I had a freshman course in chemical engineering. So this is before mass and energy balances. Most of the course was things like algebra with unit conversions, right? So he took an equation from a fluid flow course that obviously we had not seen. We didn't know the theory behind 90% of the equations we were solving. Like I said, it was mostly just unit conversions. And he just deletes a parameter from this equation. He says, solve this. And this is like 1/4 of the test. Of course, nobody gets it right. He hands it back. Everybody gets a 0 on this problem. And he says, all right, you'll get half credit if you can solve it again. You get to do it for homework. So we all do it for homework. And then he goes, all right, we're going to do it one last time. We're going to have an in-class quiz, and we're going to try to solve this problem. We're freshmen, you got to remember. At some point, somebody was just like, it can't be done. And he's like, how do you know that? He goes, because you, basically. Because you're the only reason why you would be doing this is if the problem had no solution. He didn't know it had no solution because the guy deleted a parameter. But that's, he had caught on at least at some point. I never did. I'm too trusty. Okay, part C. Oh yeah, we got C and D. Now you guys can leave whenever you want. It's just review, but I'm not going to be offended. Explain why the PBR system with the purification unit provides a higher conversion than a PBR packed with the same total amount of catalyst.
Can you repeat that?
Yes. So I had this unit, right? There's 2 packed bed reactors with a purification unit in between. It says explain why the purification unit leads to a higher overall conversion than a single PBR with twice, the same total amount of catalyst.
Because of the rate.
Yes, because B inhibits the rate of the reaction. So you can do some mathematical stuff to show it, but that's enough of an answer in my opinion. The outlet pressure for PBR1 is actually 2.5 bar for the operating conditions specified above. So remember we had inlet pressure was what? calculate the constant that relates the pressure drop parameters in reactors 1 and 2. Assume that the molecular weights of species B and C are identical. Does removing the purification unit cause the second pressure drop parameter, which is alpha 2? Does it cause alpha 2 to increase or decrease? Support your answer with calculations to receive credit. So we'll move through this one somewhat quickly. Yes. So alpha 1 is what? Everybody remember where this comes from, right? 3.5 G1 squared, where 1 just means for the first reactor. The cross-sectional area of the first reactor. The density of the catalyst, which doesn't depend on which reactor you are because there's only one catalyst. The inlet pressure of the first reactor. The density, not of the catalyst, but of the stream of the first reactor, entering the first reactor. The particle diameter, phi, and the gravitational constant. So how do I relate the first and second alphas?
Can you divide them?
Yeah, I want to take the ratio. So alpha 2 over alpha 1. What stays and what cancels out?